All right, let's talk about a challenge that pretty much every creator, engineer, and maker faces. How do you explain the complex, amazing thing you just built? Today, we're going to show you how to build what I like to call a visual encyclopedia for your tech project, turning all those tangled details into diagrams that are actually easy to understand. So, you've poured your heart and soul into a project. You've spent countless hours getting it to work. It's brilliant, it's innovative, but it's also, a super complex web of code and hardware. So, how do you document it so your team, your boss, or even you 6 months from now can understand it? That's the nut we're cracking today. For this, we're going to be looking at an awesome case study, an IoT campus energy monitor. It's a final year engineering project that tracks three-phase power in real time. But what's really amazing is its documentation. It's this complete visual guide where every single diagram was generated from a simple text prompt. It's a method that makes documenting even the most complicated systems way more accessible for everyone. Okay, so here's our roadmap. First, we'll start with that big picture, high-level view. Then we'll dive right into the hardware, map out all the software logic, take a close look at each individual component, and then, finally, we'll put it all together so you can build your very own visual encyclopedia. First up, the 30,000-foot view. Before we get lost in the details, we really need a map of the entire system. This is all about nailing down the what and the why of your project right from the get-go. Every great explanation has to start with how all the pieces fit together. And a high-level block diagram is the perfect way to do that. Think of it like the table of contents for your project. It shows all the major parts, from your sensors all the way to the cloud, and exactly how they talk to each other. Now, this is where it gets really cool. The source material for this actually gives you a whole library of text prompts. You literally copy a prompt, you paste it into an AI image generator, and boom, you get a slick, professional diagram just like this one. It's a complete game changer, and it's how we start building that first chapter of our encyclopedia. But hey, one map doesn't tell the whole story, right? A system block diagram shows you what the components are, but a data flow diagram, like this one, tells a totally different story. It shows you the journey of the information itself. You can actually trace the data from the sensor to the ESP32, up into the ThingSpeak cloud, and finally, right onto the user's dashboard. Every diagram gives you a different and really essential perspective. All right, let's get our hands dirty and move on to the next chapter, wiring the physical world. This is where we take the real-world hardware and translate it into documents that are clean, clear, and easy to follow. Okay, let's be real for a second. Most of our projects start out looking something like this, don't they? A functional breadboard prototype. I mean, sure, it works, but it's a total bird's nest of wires that only you can possibly understand. This is not documentation. But this is the goal. Your final documentation should look like a clean, color-coded wiring diagram where every single connection is crystal clear. And yep, this was also generated from a text prompt. It's a universal map that lets anyone, your teammate, your professor, anyone, build or debug the hardware, no questions asked. And to really round out the physical side of things, you gotta show what it looks like when it's all put together. A 3D rendering of the enclosure, showing the LCD, the ports, the internal layout. It documents the mechanical design. It answers that all-important question, how does this all fit together in a nice, neat little box? Okay, hardware is covered. Now it's time to map out the digital brain of the operation, the software logic. And for this, we're going to use the Unified Modeling Language, or UML, which is basically the standard way to create a visual blueprint for code. For the software, our encyclopedia tells a story using a whole suite of diagrams. It kicks off with a use case diagram, like this one, which just shows what the system does and who interacts with it. And just like before, you can generate it from a simple prompt. But this is just the start. The full library has activity diagrams for workflows, sequence diagrams for timing, class diagrams, the whole shebang. And of course, there's the classic flowchart. It's absolutely perfect for showing the firmware's main loop. You can see the whole process, step by step, start, connect to Wi-Fi, read the sensors, send data to the cloud, update the little display, and then do it all over again every 15 seconds. It makes the code's logic instantly understandable, and you don't have to read a single line of C++ to get it. Okay, so we've seen the forest. Now let's go look at the individual trees. It's time for a deep dive into the building blocks. After all, a great encyclopedia needs a really detailed glossary, right? So, meet the key players. We've got the ESP32, that's the brain, The PZM004T sensors, those are the meters. The enclosure is the protective shell. Then, up in the cloud, ThingSpeak acts as our database, and Grafana is what we use to create those beautiful dashboards. Each one has a critical job to do. So let's zoom in on the brain, the ESP32. On the left, you see the actual physical chip, but on the right, you see a functional diagram that explains its exact role in this project, its inputs, its outputs, what it's processing. This level of detail for every single component is what makes your documentation so clear and easy to reproduce. And we give the exact same treatment to the PZEM-004T sensor. We see the hardware, and right next to it, a diagram that explains what it's measuring, what its data looks like, and its key specs. It's this granular, piece-by-piece detail that elevates your documentation into a truly useful visual encyclopedia. So, let's tie it all together. How do you actually build your own visual encyclopedia? You should really think of your documentation like a book with chapters. Chapter 1 is your high-level system architecture, the big picture. Chapter 2 is the physical build, with all your wiring and enclosure diagrams. Chapter 3 maps out the software logic with all those UML diagrams. And Chapter 4 is your detailed parts list, with a functional breakdown of every single component. And here's the main takeaway, the thing to remember. Great documentation is so much more than just a folder of disconnected diagrams. It's a cohesive story. Each diagram, whether it's a block diagram, a wiring schematic, or a flowchart, is just a different narrator, telling that story from its own unique and vital point of view. So why does all this matter? Well, because clear, comprehensive documentation is how you validate your work. For this project, it was the key to proving a cost reduction of over 95% compared to commercial systems. The diagrams didn't just explain how the system worked, they proved its value. So for your next project, don't just build something that works, build its story. And ask yourself, what story are your diagrams going to tell? Thanks for watching.